For this last example, we're going to find the cosine of s plus t and the cosine of s minus t, knowing two things. First of all, I know that the cosine of s, or I'm given that the cosine of s is negative 8/17 and the cosine of t is negative 3/5. Now s and t are just two angles, right? And I'm specifying here that those two angles are in the third quadrant. So if I've got two third quadrant angles, the cosine's got to be negative. Right, because tangent and cotangent are the only positive trig functions in the third quadrant. So they have to be negative, that makes sense. And so I've got two angles here that have different cosine values, right? And what I want to do is find cosine s plus t and cosine s minus t. Now I don't know what these angles are, no idea. I could find them using an inverse cosine, but I don't want to deal with a bunch of decimals. I can actually solve this without knowing s and t. I don't need to know what those angles are. They may be really ugly, decimal radians or decimal degrees that are, we'd have to do some rounding and it just becomes a mess. And so if we can solve this without figuring out the angles, just knowing they're in quadrant 3, that's ideal. We're going to be able to do that using these two formulas, okay? Let's start with s plus t. To find the cosine of s plus t, I need to know the cosine A, cosine B, or s and t, which I know, but I also need to know sine of s and sine of t, all right? Well, I don't yet know those things. However, I can find them because I know that, let me think about how that works. Well, yeah, so I know that I can construct triangles, right, to find the sine. Okay, I know that I can. I'll explain how that works to you guys. So if I construct a triangle, now this triangle should be actually in quadrant 3, so maybe I should draw it that way. Yes, let's draw it that way. Let's actually place this on a set of axes. Okay. So the cosine, remember, is x over r, correct? So it would be adjacent over hypotenuse. So that's going to be negative 8 over a hypotenuse of 17. Now I don't know exactly where this angle is going to land in the third quadrant. I'm just drawing something arbitrary so I can put some labels on it. Okay, so there's a right angle in the third quadrant. The angle S would come around like so. And negative 8 is your x value because the cosine is x over r. Okay, so this would be negative 8. That gives us an 8 on the horizontal side and a 17 on the hypotenuse. We still need to find the y, the vertical side, and that's going to allow us to get the sine. So the vertical side here we can find using Pythagorean Theorem. We'd have the square root of the hypotenuse squared minus the other leg squared, right? So Pythagorean Theorem, you would add the legs, the square of the legs to get the hypotenuse, but if you don't know the leg, you take the hypotenuse squared minus the other leg squared to get the other, the unknown leg. So here, 17 squared, I gotta punch that in. 17 squared, 289, I should know that. 289 minus 64 is 225. I'd almost think they planned that. And 225, square root of 225 is 15. Right? So 15 is the square root on that side. And so let's see. That's going to be our vertical side there. So that means that the sine of s is equal to the opposite over the hypotenuse, or the y over r. That's 15 over 17. However, it's also negative 15 because it's in the third quadrant, right? So it's negative 15 over 17. There's our sine value. Repeat the process for angle t. So for angle T, I would do a similar diagram. Again, I don't know exactly where that angle is. but I just need to draw something in the third quadrant. Angle T comes around. The horizontal side is the -3, so it's a 3 length. Excuse me. The hypotenuse is 5, and so I can again find the vertical side by taking the square root of the square of the hypotenuse minus the square of that leg, which is 9, okay? And in that case, 25 minus 9 is 16, square root of 16 is 4, so that gives us a 4 on that side, but again, it's negative because that's a y value in the third quadrant. So the sine of t is going to be -4/5, right? It's opposite over hypotenuse, y over r. Okay, so now I've got all my cosines and sines that I need. So if I look up here, I got the cosine of s plus t, using my formula as cosine s cosine t. Minus sine s sine t, and then I just plug in all the values, right? So cosine s is -8/17, cosine t is -3/5, sine s is -15/17, and the sine of t is -4/5. All right, got lots of negatives to take care of. Double negative here, they cancel out. Don't really have any other factors I can cancel. 8 times 3 is 24. 17 times 5 is 85. I've got a triple negative here, so that stays a minus. 15 times 4 is 60. 17 times 5 is still 85. It's kind of nice when that happens. I've got a common denominator. 24 minus 60 is -36 over 85. Question is then, does that reduce? 36 has factors of 2 and 3. 2 does not divide 85. 3 does, right? 85, 8, and 5 add up to 12. So, no, it doesn't add up to 13. I can't add. No. 2 and 3 don't go into 85. So that's good. -36 over 85 should be our value there for the cosine of s plus t. Now, I've only found one of the answers. I still have to find the other one. However, the other one doesn't change a whole lot, right? So let me erase some of this work over here. I don't need it. To find the cosine of s minus t, it's essentially the same formula, but with a plus in the middle rather than a minus. So I would have the same structure, except this guy right here would end up being a plus, right? So that would end up giving me a double negative, makes that a plus instead of a minus. So I really have, I'll fill in with dots because I won't rewrite all this. I'd really have 24 over 85 plus 60 over 85. And that value is 84 over 85, which does not reduce. 84 over 85, okay? Perfect. I think that covers it pretty well. I don't think we're missing anything. And so we have two values then that should work out for us. All right. Cool. So now you've seen quite a few different applications for these two formulas. In the next couple sections then, we're going to look at similar formulas for the sine and the tangent, and we'll get into their application. So we'll have sine of a plus b, sine of a minus b, tangent of a plus b, tangent of a minus b, and we'll look at how they apply to similar types of problems. All right, we're evaluating trig function values at some unknown angles.